started?
Today we're going to be talking about a bacteria called PCO6 and how it can be used to battle drought in wheat crops.
Alright, so this is a diagram of a 96 cell plate. So on this side is the abbreviation DT1, which is the drug toxicity or the toxicity of the compound on the cells. So
congratulations, you guys. I think everybody did great, even those who didn't end up in the top three. So thank you. And let's give one more hand.
Two pieces of the same heart, two halves of the same story, two harmonies to the same sound. Perfect fit, and you're getting more, and the pieces fall into place. It's incredible. Ooh, 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 it's incredible. It's incredible.
I got this from Utah State University. It's the big letter. So I'm assuming that is a good sign. I applied for the biotechnology summer camp there. And last year I also applied, but I didn't get in because it's kind of like first come, first serve, but they also choose based off your GPA, your age, and they mostly take
and your
recommendation, not your recommendation, your
letter that you
essay.
wrote. Essay, yeah.
So, and they usually, I know it's like mostly a program for juniors and seniors, but
You're a senior at heart. It's looking good, because last time we just got an email saying that we were denied. Whoa! What does it say?
Dear Mario, congratulations! You have been accepted into the 18th Annual Utah State University Center for Integrated Biosystems Biotechnology Summer Camp.
Yay!
Your high academic performance and personal ambition were all considered in the selection process. The entire staff was impressed with your qualifications.
Yes! That's so flattering!
Yay!
That
It's
sounds
so
like even
exciting.
more than a form letter.
Thank you, Cosette.
Aww.
And so yeah, I got to stay there for a week.
Yay!
Board and room.
Oh my gosh, this is gonna be so cool. We're gonna drive you up there and everything.
Where?
It's like driving you to college.
Where are we
It's
I mean, it's at a college.
Utah
it's like
State.
nice because this is a pretty nice college. This is a nice college, and
And I
it'll
love
be
Logan.
super exciting. No,
Yeah.
I'm gonna. Oh, like on the
just
way there.
for the drive, yeah, because
Oh.
it's like 2 or 3 hours from
Can't
here.
I go with? Can't Mark?
Yeah, he's gonna come
Visit
too.
me?
He'll drive us.
Oh.
Yeah.
Oh no, yeah, he'll come with us.
Oh no, I might get caught.
We'll probably do something fun on the way.
Like
I mean, while
bowling?
we're up there.
Summer
'Cause-
Academy is almost here. We look forward to meeting you and your gifted scholar. Enclosed are a tentative daily schedule and a highlighted university map showing where you can find the parking terrace, the dorms, engineering building.
There's one more thing
You're
in here.
invited to attend the presentations.
So excited.
There's one more thing in
Where
here.
on the engineering
Take it out
building
for
where
her.
we will have
It's
the
this one.
participants.
Just kidding.
Oh.
Done.
That's so
Silly girl.
exciting!
Oh, I can't wait to look at this
ripping
schedule.
papers.
Oh,
Hey, hey, stop throwing
yay!
things.
I'm so excited!
Yay!
I'll have to tell Tara that I'm gonna miss like half of
the play camp.
but it'll be okay.
Did you tell Cosette what part she got for the camp?
Yeah,
or for
she
the
got
play?
a student.
Yeah.
No.
My name is Marielle Kingsley. My name is Kate Pliska, and we
what we did was we tested the effects of plant toxins in bison. So basically, the reason why we did this is that there's a common problem where farmers are finding that a lot of their cattle and sheep and different livestock are getting severely harmed from grazing. They'll get into plants they aren't supposed to, and so we are trying to solve this problem by finding out how these toxic plants, specifically we are working with local weed, we're trying to find out how these plants affect the different animals. And as you can see right here, this is actually local weed right here on the side too. It comes in different colors, but this cow is just grazing on it, and they don't really know the effects of it. And past tests have been done on how local weed affects the different species using hypothesis local weed poisoning expression is sex specific, but we are diving deeper into this and instead testing the difference in age and sex in the different bison.
Okay, we are testing alpha-D-manosidase in bison blood serum using a fluorescent kinetic assay, and then resirufin, which is a colored dye. We're using red fluorescent resirufin as a standard. So the procedure, we use a serum concentration in a 1-to-1 ratio. So we use the serum extracted from bison blood samples, and then in a 1-to-1 ratio with the buffer of sodium acetate. And then we put this into the assay and read 1 minute for 30 minutes at 550 and 595 wavelength with the auto cutoff. So we read the tray in the assay from the bottom, and we're using fluorescent lighting to read it. So the standards we use are 100 microliters of 5, 10, 20, and 50 micromolar of resirufin, and then we use swintonine and serum and resmin, and tested this in, as you can see on the chart, in the male adults and female adults and male juvenile and female juvenile. So the swintonine serum, we added 40 microliters of swintonine, which is actually the toxin found in local weed. So that's what we're testing. At 0 nanomolars, 10 nanomolars, 50 nanomolars, 250 nanomolars, 500 nanomolars, and 10K nanomolars. And then we added the 10 microliters of the serum, which mentioned before was in the 1-to-1 ratio with the reaction buffer. And then 50 microliters of resmin, which is just an abbreviation for resirufin, the dye.
And so this chart right here, we had little containers that we would pipette the swintonine, resirufin, so like the serum and the poison, we'd pipette into this container that had the same grid as this chart as we went on.
So here's our data, and as you can see with the male data, which is on the top, but at the higher concentrations, the line is completely flat, which means the manosidase is completely inhibited. So that means it causes the harmful effect on the animal in those concentrations. And you can see as you get into lower concentrations, it has less and less of an effect. And then with the female data, we had an issue with the calculations, and so we were not able to get accurate data for them.
Yeah, basically what happened was we didn't have enough of resirufin, of the poison, to accurately get our results. So you can see that we're getting similar data to up here in these upper areas on these two, on the juveniles, but down here we didn't have enough resorufin, so that's why these lines down here are so much lower. So basically, in conclusion, because of the calculation error, we weren't actually able to see the difference between the sex in the bison, but we did learn about the effects that the local weed has on the cells. So over on this left side, you can see these are sperm, and so what happens, the toxin, the local weed, it causes deformations in the sperm, which has reproductive effects and makes it so that these bison can't reproduce. Yeah, this
so,
over here.
Yeah, it messes with the sperm structure. And so as you can see, this one has no flagellum, which is how the sperm moves. So if the sperm can't move, they can't implant in the egg, and so you end up with a lower and lower birth rate.
Yeah. Basically just doesn't have a tail, it can't swim. Then this, on this side, this is a cell, and what happens is that it's something called vascular swelling, where this protein in the cell, this red stuff, it gums up and it gets really, you could call it cellular constipation. And what it does is it impairs proprioception, which basically the animal doesn't know where it is in space. So it'll freak out if it tries to move around, and
it can't, it doesn't know where its limbs are. So it doesn't understand, like, okay, if my limb's here, I cannot put my other limb over it to walk forward.
Yeah, so it just has a lot of trouble functioning. It just doesn't know where it is in space. And yeah, that's about it.
We would love to thank Dr. Ben Green for having us in our lab, and Anita, our mentor, our lovely mentor, who decided to show up today. So thank you for that.
Okay, thank you. Any questions? Okay.
Do you know the origin of the bison samples that you tested, or did they came from like a conservation or lab starter?
The facility we worked at actually kept animals on site. So Dr. Ben Green would actually extract blood.
Yeah.
And then we'd spin it in a centrifuge and then
To
extract the
separate.
serum when
Yeah.
it was separated from red blood cells in the serum.
Did it affect the female reproduction system at all?
Well, okay, you can go.
Not that we know of, but we also did get very good female data, and we didn't study the female reproductive effects.
Does local weed, does that have any positive benefits to the ecosystem?
Yeah, none that we know of at the
We
moment.
weren't focusing on the plant itself. We were focusing on the toxins inside of the plant and how it affects the animal.
And through finding out what those toxins do and how it affects different genders and age, which actually, if we go back, we'll see, you can see it doesn't really actually affect the age, but it's just, basically we're just, testing the toxins in the animal, and we could see, and using that data, we're able to, in the future, prevent problems from livestock eating these plants.